Hello, my beautiful and wonderful, lovely people. How are you all doing? Um, as the title shows, today we're going to be talking about the fifth factoring type, which is the AC method. Now, before we get started on that, why do you think it's called the AC method? Well, first of all, what does AC mean as an algebraic expression? In other words, if you just saw AC, what would that mean? Well, if you're shouting, it means A times C, then you are absolutely correct. Okay, well, that's great, Mr. Bahi, but where do the A and C come from? Well, if you notice our little expression buddy over here, it's highlighting what the A and C parts are. Now, if you remember, this is a standard form of a quadratic. We have a standard form of a quadratic, and A and C would just mean the number in front of the x squared times the C value, which is the one that doesn't have an x. Now, are these always going to be quadratics that you have to factor? Not necessarily, but this is just more when you have three terms and you're trying to factor these out. So now, if you look at number example, you're probably wondering, well, why is this different than what we were doing before? And if you remember from, where was it? This one, like when we had a regular trinomial, this is from a couple Fridays ago, I believe. So how come we can't just do what we did here? Well, with these problems, there was a GCF that we could factor out first, as noted here. So the issue with this one is that there's really no GCF I can take that we can take out. So, we have 3 as our A value that goes into 12, but it does not go into negative 20. So there is no coefficient that I can take out as my greatest common factor. So let's focus on these two. What is A, what is B, and what is C? So A is 3, B is negative 20, and C is positive 12. This is a little too thick. There we go. So just like we had done previously with our RBF method, if you will, we were trying to find two numbers that would multiply to the last number but add to the middle number, right? So it's kind of like the same thing with the AC method, except with the AC method, you're not trying to see what multiplies to 12. You're trying to see what multiplies to AC. So what is AC in this case? Well, what's 3 times 12? That's going to be 36. So we're temporarily going to think of this number. And we're going to try to think what multiplies to this. And adds to negative 20. And the reason for that is because, well, one, there's no numbers that multiply to 12 and would add to negative 20. Also, because our A value is not 1 and there was no GCF, no matter what, you got to remember that with the numbers that you pick here, well, first of all, this would be a 3x and an x instead of just x and x like we've been doing. So we have a 3x now that we have to consider, and we got to consider numbers here and here, where that if you were to distribute, you would have to, those numbers would have to multiply, those numbers would have to add to negative 20. And because there's a 3 over here, it makes a lot of, it makes you do a lot of guessing and checking. Nobody's got time for that. Come on, let's be for real now. So what the AC method does is that it skips that guessing and checking and gives us just a concrete route as to how to approach this. So what multiplies to 36 and adds to negative 20? And those numbers would be, you got it, negative 18 and negative 2. Okay, so now notice I'm not putting the 36 anywhere here. This was just our temporarily thought of number. So here's you thinking, and you should be smiling because now that you know the AC method, you're thinking what multiplies to the 36 and adds to negative 20. We got negative 18 and 2. So what we're going to do with these two numbers, let's highlight them in blue, is I'm going to take the B value, which is negative 20, and I'm going to separate it into those two numbers that we just found. Okay, so I have the 3x squared minus 18 and then the minus 2. And of course, we have to add an x next to both of them. And then plus 12. So it's kind of like we're combining like terms, just for the middle part. And what that does is that it gives us 4 terms. And what did the wise men say about how to factor when there's 4 terms? You factor by grouping. Okay, so factoring the first half, we have 3x, and then we're left with x minus 6. Factoring the second half, we get negative 2, and then we're left with x minus 6. Our parentheses match. That means we did it properly or correctly. Your math teacher will be very proud. I know mine is. And then we're left, and then we put the remainders there, and there's your factored form of the original problem. Okay, let's move on to the next one. First thing you should always do, see if there's a GCF, which according to inside sources, there is no GCF. So let's see, what would be A times C? So AC in this case would be negative 24. Now, I'm not going to write that negative 24 in the original problem. We're just going to temporarily ponder this number and think about what two numbers multiply to negative 24 and add to negative 10. And those two numbers just happen to be negative 12 and positive 2. And by the way, it doesn't matter if you write the negative 12 first or whether you write the positive 2 first. It doesn't matter. They're both going to work. That's the beauty of factoring by grouping. I mean, I'm trying to tell you guys, that's just the beautiness of math. You know, it's amazing. So anyhow, I'll stick with the second one. Don't erase the whole world, Mr. Brahim. So now we're going to rewrite the original problem. And now I'm going to split the middle term, the b value, as a sum of those two numbers that we just found. So 3x, and then instead of negative 10x, I'm going to have a positive 2 and a negative 12. And we got to hit them both up with some x's, otherwise they wouldn't combine to make negative 10x, and then minus 8. Okay? So now don't combine these two, obviously, because then you're just going to go back to this step. Again, we're uncombining like terms just so we can have 4 terms, giving us the ability to factor by grouping. So the GCF from those two is going to be x, and we're left with 3x plus 2. And the GCF from these two would be negative 4, leaving us with 3x plus 2. Beautiful, we did that right. Our final answer is x minus 4 and 3x plus 2. Okay. Why don't you guys try this one out? And if you're wondering, timeout, I've seen this problem before. You'll never guess where you've seen this. Considering this is our 5th factoring tab, I hope you guys get the gist as to where I'm going with this. So try this out. I would pause it to see if you did it right. It's the best way to check your work. And then unpause it. By the way, the answer to where you've seen this before was on your factoring pre-assessment. Okay, so here is the final answer. 3x plus 4 times the quantity x minus 2. All right, hope this helps. Your homework is to complete the slides that are titled AC Method. And I hope to see you all very, 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 very soon. Take care, everyone.